A panorama of the interior and rim of Gale crater, which is a large impact basin formed around 3.7 billion years ago. The crater spans about 96 miles in diameter and holds Mount Sharp in its center. Gale crater formed when an asteroid or comet punched a hole in the terrain, and the subsequent explosion ejected rocks and soil that landed around the crater. Some scientists believe the crater filled in with water and sediments, and over time the relentless Martian winds carved Mount Sharp, which today rises about 3.4 miles above the floor of Gale. Layering in Mount Sharp also suggests it is the surviving remnant of an extensive sequence of deposits. This view shows how the appearance of dark markings on Martian slope changes with the seasons. The marks, called recurrent slope lineae, extend down slopes during warmer months and fade away during cooler months. The time-lapse shows the same location at several times of year, and the location is in a crater on the floor of Valles Marineris near the Martian equator. This image shows the Mars Pathfinder lander along with the Sojourner rover on Mars. Mars Pathfinder was originally designed as a technology demonstration to deliver an instrumented lander and a free-ranging robotic rover to the surface of the red planet. Both the lander and the 23-pound Sojourner rover carried instruments for scientific observations and to provide engineering data on the new technologies being demonstrated. Included were scientific instruments to analyze the Martian atmosphere, climate, geology, and the composition of its rocks and soil. From landing until the final data transmission on September 27, 1997, Mars Pathfinder returned 2.3 billion bits of information, including more than 16,500 images from the lander and 550 images from the rover, as well as more than 15 chemical analyses of rocks and soil and extensive data on winds and other weather factors. Findings from the investigations carried out by scientific instruments on both the lander and the rover suggest that Mars was at one time in past warm and wet. Sojourners spent 83 days of a planned 7-day mission exploring the Martian terrain, acquiring images and taking chemical, atmospheric and other measurements. The final data transmission received from Pathfinder was on September 27, 1997. Although mission managers tried to restore full communications during the following 5 months, the successful mission was terminated on March 10, 1998. A region-wide seasonal dust storm obscures the Zero crater in this image from Perseverance rover. The view shows part of the northern fan, a part of Zero crater that Perseverance never drove through, but is an area that's thought to have been deposited in a similar way to the delta that the rover did explore. Dust activity is typically highest around early spring in the northern hemisphere on Mars. The increased dust at the time made views back toward the crater hazier than usual and provided atmospheric scientists with a great opportunity to study the way that dust storms form, develop, and spread around the planet. The bands of rocks seen here may have been formed by a very fast-flowing deep river in the past. The curved rock layers are called the curvilinear unit, and they had previously only been seen from space. It is still a mystery, however, what kind of powerfully flowing water formed these curves. A river like the Mississippi, which winds snake-like across the landscape, or a braided river like Nebraska's Plateau, which forms small islands of sediment called sandbars. When viewed from the ground, the curved layers are arranged in rows and appear to ripple out across the landscape. They could be the remnants of a river's bank that shifted over time, or the remnants of sandbars that formed in the river. The layers were likely much taller in the past though, as scientists suspect that after these piles of sediment turned to rock, they were sandblasted by wind over the course of eons and carved down to their present size. The wind-sharpened rocks seen here are called ventifacts and almost look like the back of an alligator because of their scaly appearance. Rocks like these are responsible for damaging Mars rover's wheels and has led rover engineers to find ways to slow wheel wear, including a traction control algorithm. They also plan rover routes that avoid driving over such rocks, including these latest ventifacts, which are made of sandstone, the hardest type of rock rovers have encountered on Mars. The rocks form the surface of a broad sloping plain in the foothills of Mount Sharp. The floor of a Gale crater is also visible along the edges of the panorama. When Curiosity's team saw the Gatorback rocks, they ultimately decided to turn the rover around and take an alternative path to continue climbing Mount Sharp. As it climbs, Curiosity is able to study different sedimentary layers shaped by water billions of years ago. These layers help scientists understand whether microscopic life could have survived in the ancient Martian environment. These blocks of layered material have been eroded by the wind into the scenic landscape we see here. These blocks of layered terrain are located within the Olympus Mons aureole. The aureole is a giant apron of chaotic material around the giant volcano, perhaps formed by enormous landslides off the flanks of the volcano. Perseverance rover captured this panorama of an area located on the rim of Jezero crater on October 22, 2024. Perseverance landed on the crater's floor on February 18, 2021 and has been steadily working its way up and out of the crater since August 2024. The rocks here are among the oldest yet found by Perseverance, forming in a different geologic era than almost everything the rover has seen before. They are likely part of the original surface that existed before Jezero crater's formation by a massive asteroid about 3.9 billion years ago. The rocks here are mostly made of volcanic minerals like olivine, plagioclase, and pyroxene. In the far right corner of the panorama is a field of white cobbles. This represents the first time Perseverance has encountered pure quartz rock, which may have been created by a hydrothermal system like hot springs. An environment life could have survived in if any existed on the red planet billions of years ago.